Start recording. Okay, we will continue with chapter 2. Chapter 2, exponential and log. Okay, so in order to do exponential and log, let's do some revision first. Okay, so number 1 is the indices rule. Okay, we have a plus a plus a, right, as a ka, 2 a times a times a, right, as a power n, 3 am multiplied by an equals to am plus n, 4 am divided by an equals to am minus n, 5 I have am power n equals to amn equals to n power m. Okay, number 6, you have a power of 0 equals to 1. Number 7, a power 1 equals to a. Number 8, we have a power of negative n equals to 1 over an. Number 9, we have a power of 1 over n equals to n root of a. Number 10, a of m over n equals to n root of am, or n root of a power by m. Number 11, we have a power m times b power m equals to ab power m. Number 12, we have a n m divided by bm equals to a over b power m. And for further math students should know the proof. Okay, for further math students to know the proof. Okay, why are they true? Okay, so this is just a revision. Number 2, back to MS that we have before, we have log rules. Okay, now you'll need to know about log rules. Log rules, number 1, we say if ax equals to n, then log base a n equals to x. Okay, but there will be some students that are having difficulty to actually remember this. Okay, to actually remember this. So there is one of the best way to actually remember that. All students know the value of 10 power 2 equals to 100. All students know this. Okay, so how to actually memorize them and write in the form of log OB? Okay, you see that you'll see this, there's a 0 here, there's 0, 0 here, then log, you also have a 0, so you write like this. You can actually, that means you actually just put all the 0 on the same side. Okay, you put all the component with the 0 on the same side. So that will be the rule that you can actually remember. Okay, 10 squared equals to 100, log of 10, 100 equals to 2. As long as you follow this position, okay, then your log and indices is not going to go wrong. Number 2, log of a m plus log of log of ab plus log of ac equals to log of abc. Okay, number 3, log of ab minus log of ac equals to log of ab over c. Number 4, n log of a b power n equals to n times of log ab. Okay, then number 5, if we have a log of a equals to 1. Number 6, log of a1 equals to 0. Number 7, we have log of 1 over b equals to negative of log ab. Number 8, we have a log of ab equals to log of cb over log of ca. Number 9, we have log of AB can be written as 1 over log of BA. Okay, any rules that I left behind? Okay, that should be it. Okay, so same thing, we would like to know about the proof. Okay, for all of these log rule that we have here. So how do we actually understand the proof? Y plus become multiply. Okay, for example, y plus become multiply. Let's see. So the proof for 2. Okay, so the first you let log AB equals to L, log AC equals to M, log ABC equals to N. According to the indices rule, okay, according to rule 1 for the log, okay, the changing in between of indices and log, we know that this can be written as L equal A power L equals to B. This will equals to A power M equals to C, and this will go to A power N equals to BC. So that will be from the definition, okay, of log. So A power L equals B, A power M equals to C, A power N equals to BC. So you can see that there is a B component here, and there's a C component here. Therefore, I can replace them in. So over here, according to indices rule, it becomes A of power L plus M. Because they are the same base, therefore N equals to L plus M. So you can see that L plus M equals to N. It is true. Can you understand? Okay. Then, okay, from the past, your teacher may be just telling you that the rule is true and memorize them. But right now, we are talking about whether you understand the reason or not. Okay, for number 3, okay, we let log AB equals to L, log AC equals to M, log of A B over C equals to N. Let's see what happened. Okay, so according to the first rule, I have A power L equals to B, I have A power M equals to C, I have A power N equals to B over C. So I have a B over C here. That means I can actually replace it by AL and AM. So I have AN equals to A power L over A power M. According to the indices rule, this is A power of L minus M. Since they are the same base, you can see that N is actually L minus M. So log AB minus log AC equals to log AB over C. It is true. Okay. Number 4. Log of AB power N. Why the N can actually put to the front? Okay, what exactly is the reason that N can be put to the front? So over here, log A B power N here actually means B times B times B. There's log B there. Okay, according to rule 2, when you have multiply of two items, you can write them in the form of plus. Therefore, over here, I can write them as log AB plus log AB plus log AB until the last one. So in the end, how many log AB do I have here? I have total of n of them. So I have n times of the log AB. This is why n can actually put to the front. That's the reason. Are you okay? Okay. Number 5. Number 5, log AA equals to 1. Again, why is it so? Okay, it's come from our indices rule of a power 1 equals to a. Okay, it's come from our indices rule of a power 1 equals to a. We just don't write the 1 there, isn't it? Okay, but if we follow the rule 1, the formation, okay, how are we supposed to write the formation? You will see that this can be written as log. This a is placed over here. This base a placed over here. This 1 will be placed over here. Therefore, it's true. Can you understand? Okay. Number 6. I have log a 1 equals to 0. Similarly, why is it so? It comes from our indices rule. From the past, we already know that a power 0, any base power 0 equals to 1. Okay, and you already know why is it true. Then over here, according to the formation, you will see that the 1, okay, write the log, the 1 you can place over here, the a you can place over here, the 0 you can place over here. Therefore, log a1 equals to 0. It's true. Are you okay? Okay. Then, number 7. Log a1 over b equals to negative log ab. Okay. Number 7. Log of a1 over b equals to negative of log ab. Why is it so? Okay. So we will see that, okay, log of a1 over b, according to rule 3, divide can write in the form of minus. So that means I can write in the form of log a1 minus log ab. Okay, and from rule 6 here, log a1 is 0. So 0 minus log ab. Therefore, you have a negative log ab. Are you okay? Okay. Number 8. Number 8, we have log ab equals to changing base. Okay. So log ab equals to log of cb over log of ca. Yeah. So the changing base rule says, okay, if you have log of anything a, b here, you can always replace by a new c, okay, and write the b on top, the a below. They have the equivalent value. So, but why is it so? Okay, so we let, okay, L equals to log AB, let M equals to log CB, we let M equals to log CA. According to rule 1, okay, we write in the form of indices. So A power of L equals to B, C power of M equals to B, C power of N equals to A. So if we write them properly, we can see that B equals to A power L equals to C power M. And the A itself is C power N. So I replace them inside. According to the indices rule, okay, we will have a C of NL equals to CM. Since they have the same base, then you will know that NL equals to M. Hence, L equals to M over N. It's true. You will see that L log AB equals to M log CB over N log CA. You know that is true. Are you okay? Okay. Then number 9. Number 9, we have log of AB equals to 1 over log of BA. This tells us that the AB and the BA can actually switch position. Okay, and they actually switch positions. Why is it so? So let's see. So log of AB, according to rule 8, I can replace by any base. Okay, I can replace by any base. So I decided to replace by base B. So log BB from rule 5, okay, the same value, we have 1. So I have 1 over log BA. This is very easy to understand. Are you okay now? Okay, we're explaining the rules for all the logarithm rule. Why is it like that? Why is it like this? Okay. Then after this log rules, okay, then number 3, okay, students need to know how to solve algebra using indices and log. Okay, of course, students need to know what kind of algebra may be involved. Maybe simultaneous equation. Okay, showing, proving. Okay, maybe quadratic. Okay, maybe involved with anything with P3 chapter 1. Okay, so students will be expected to solve the algebra. Okay, so let's see. Okay, before we actually go for the example, okay, 2 specific things that you need to know. Okay, E number 4, item number 4. Before we actually go into the example, you need to know E first. What is E? Okay, so the E that you've been using in physics, or maybe if you go into university, you see that in econ study. Okay, so E is a number. Okay, is equals to, if you press calculator, E, so you have a 2.718281828. Okay, this value is an irrational number. Okay, that actually happen in nature. That means in our real world, there are a lot of things that are actually related to E. Okay, and secondly, the Ex is one of the 2 functions in the world that differentiate of it equals to itself. Differentiated equal to itself. Okay, so how did people actually discover this value of E anyway? Okay, so we look at the definition of E. Okay, So E is defined as limit of n tends to infinity of 1 plus 1 over n power n. Okay, so now let's look at the table. Okay, let's look at the table. So let's say I have n, 1 plus 1 over n power n. You can do it together with me if you have a calculator. So let's say I put 1 here. So I put 1 plus 1, 2, 2 power 1 is 2. So this is 2. When you have put 2, 1 plus 1 over 2, so 1.5, 1.5 power of 2. So 1.5 power 2. Yeah. 1.5 power 2, do I get? I get a 2.25. So if I put 3, okay, I will have a 4, 1 plus 1 over 3, so 4 over 3, okay, power by 3. So you will see that I have a 2.37 something, 37037. So let's jump further to 10. What's going to happen? So if I go to 10, okay, if I go to 10, so I will have a 1.1, 1.1 power of 10, 1.1 power of 10. So I have a 2.593742446. Let's go higher, 100, 1.01 power 100. So I have a 2.7048133829. I go for maybe, okay, 100,000. Okay, so 1 divided by 100,000, okay, plus 1 power by 100,000. I have a 2.71828268237. I go for 90 at the back. Okay, if I go for 90 at the back, 1 divided by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 1, power 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have a 2.718281828. Oh, it's already big enough. Okay, that means when it goes to infinity, it gives me the value E. This is how we get this number. Okay, and this thing here is a behavior that happens in our society, in our real world. It happens in biology, it happens in econs. Okay, this is the reason why the E happen in around us. Okay, this is a reason why E happen around us. So E is defined as limit of n goes to infinity, 1 plus 1 over n power n. Okay, so alternatively, we also have Ex defined as limit of n goes to infinity of 1 plus x over n power n. Okay, so remember earlier, I say that Ex is one of the two functions in the world that differentiated equals to itself. So why is it so? So if I want to differentiate Ex, that means I differentiate the limit of n goes to infinity, 1 plus x over n power n. Okay, so the limit and differentiation can actually switch places. So ddx of 1 plus x power n here. So limit, leave it there, don't disturb it. So we differentiate this just like how we differentiate for our P1. So bring down the power minus by 1, multiply by differentiate of the inside. So you'll see that the n here cancels off. You're left with this. 1 plus x over n power of n minus 1. since n goes to infinity, okay, so you'll see that this expression here and this expression here, there's no difference. Okay, because it's just minus 1, because n goes to infinity, therefore this is ex. This is why it's true. Can you follow? Okay, so this is why we have e. Then, since this e is a number, since e here is a number, it follow whatever the indices rule that we actually use happen here. It follow exactly. Okay, so after that, that's number 4. Number 5, natural log. Okay, so we have log base e. Okay, log base e. So then over here we can read it as a ln x. By the way, ln x here or ln x here, in the world of mathematicians, they actually have a argument about how to pronounce them. Okay, for me, I've been using it for saying it in the terms of ln. Okay, since young. Okay, so for many years, but there are some group of there are other groups of mathematicians that refuse to actually say like that. They say that it cannot pronounce as ln, it should be lnx. Okay, so it'll be up to your teacher when you actually encounter this. So some teacher will just say that lnx. Okay, so natural log. Okay, so that means in order to write loge, okay, so we actually can write as ln. Okay, instead of writing loge, we write as ln, so that can actually carry the same meaning. Okay, so this is the natural log. Okay, so since this natural log, all the rules here actually apply. Oh, I know what I'm missing already. Okay, I'm missing 2 additional rules. Sorry, I still have rule 10 and rule 11. Now I recall. So rule 10 is log a of ak equals to k. Rule 11, a power log ak equals to k. Okay, so let me recap, fill in for the 10 and 11. There was something that I've forgotten. So this one I put it later. Okay, for the rule 10 first. 10. I have log of ak equals to k. This one is actually quite easy. Okay, so we have a log of ak. So k here is actually a multiple. We know that according to rule 4, the power can actually bring to the front. Okay, the power can bring to the front. So k of log AA. So since log AA is 1, so it's left with k. So you know that this is true. For 11, a power of log AK equals to k. For those who have a calculator, okay, you actually can try to key in this. You will see that there's a log button. Okay, log with any base button. So let's say you key, like let's say 8, then you power by log 8. You just replace this by any number. Let's say 5. You press calculator, equal, then you get 5. Do you manage to test it? Okay, so this rule is true. If you press calculator, you know that this rule is true. The reason is why. Why is it true? So first, we let y equals to a power log ak. According to the indices rule, okay? According to the indices rule, so I have a log, the logarithm rule. Okay, this is a serve as a power. This one serve as a place is a value. So I have a log ay equals to log ak. Okay, so this is a power. The power we put here. Okay, just maybe I just write on the side a power x equals to n log an equals to x. Okay, so over here now you see that there is a log a and a log a on both sides. So of course the log a can be cancelled off. Well, y equals to k. So a is k. It's true. Can you see it? Okay. So this one will be rule 10 and 11. Okay, rule 10 and 11. So okay, because ln here is the same as whatever the log rule that we have previously, therefore all the logarithm rule applies over here. So such as ln of ab equals to ln of a plus ln of b, ln of a over b equals to ln of a minus ln of b, ln of ak here equals to k of ln a, ln of 1 over a here equals to negative of ln a, ln of e equals to 1, ln of 1 equals to 0, ln of what else? Ln of okay, ln of ek equals to k. Okay, e power of ln k equals to k. So you can see that all of these rules actually apply. Yeah. So the first thing first, the lesson for today that you need to do will be practicing for the algebra. Okay, so therefore we will look at the algebra questions. Okay, we'll look at the algebra questions. Solving algebra. Let's see whether you have any algebra question that you can do. Okay, before we go far away, so further we deal with the algebra question first. Okay. I don't have a lot of algebra questions. Okay, let me see, got any more or not. Okay, I don't have a lot of questions here, but maybe to let you get the hang of it and get used to it first. Okay, let me see whether got any simultaneous equation. Wait for a while. Simultaneous equation. Okay. Okay, this is better for you. Okay, this whatever that we're doing here, we are focusing on the ability to do algebra questions. Okay, and I'm not going to give you answers. Okay, I'm not going to give you answers. I want you to use your calculator to verify answers yourself, to see whether you are able to get them correctly or not during exam, especially during exam. Okay, so uh, next is, do you need me to show you any questions first? Okay, or else I'll just send this to you. Okay, I'll stop recording first.